So lesson number 4 in the statistics chapter looks at using z-score tables. So if you recall the normal distribution curve that we looked at last week, the numbers at the bottom represent the number of standard deviations above or below the mean. The mean is equal to 0, 1 deviation, 2, 3, -1 for below, -2 for below, -3 for below. 34% of the data approximately lies on either side, 1 standard deviation, or 68 in total. 13.5, 2.15, and 0.13%. At the back of your workbook, and actually as a handout that has been given to you today, is something that's called a z-score table. What the z-score table does is it gives you the area to the left of the data value. So, for example, I know that the data to the left of 0 is half. It's 50%. 1 standard deviation would be the 34.13 plus that 50%, which would be 84. So 84.13%, which as a decimal would be 0.8413. So if I go to the data tables, you have 2 sets, 2 pages to your data table. These are all the negative z-score values, and the next page is the positive z-score values. So if I look at 1.00, there's my 0.8413. That's the area to the left of the z-score table. The area to the left is denoted by a capital A and then the z-score. So there are some properties. The z-score for a data value describes the number of standard deviations above or below the mean. A negative z-score indicates that the data value is below and it's shown to the left. A positive z-score means that the data value is above and it is shown to the right of the mean. The z-score table gives you the area under the curve to the left, which I can then determine or change into a percentage. So I can also get the percentage of the data to the left, or the probability that a randomly chosen data value is to the left. Mean, median, and mode all have scores of 0. When you are using z-score tables to make calculations, you want to sketch the curve. It will help you to visualize. So on the normal curve shown, shade the region denoted where the z-score is less than -3. Or in other words, the area is -3. So if I think of my z-score or my normal curve, -3 is 3 standard deviations away. There would be -3. I want the value that is less than -3. That's this in here. So that's to the left. So if I want to determine the area under the curve for this, I go to my z-score table and I want -3. So I want that negative table. -3.00 is 0.0013. That's the area to the left. So this would become the area of -3 would be 0.0013. And if you go up to the top of the page, the area to the left of -3 is 0.0013. So it says use the z-score table to calculate the following. So I want the area to the left of -2. -2 is here. That's the area that I want. So I go to my z-score table. I want -2.00. There's negative 2.09876 all the way to here, and I get 0.0228. So what I want you to do is press pause and take a moment to find the area to the left of a z-square value of 1 and the area to the left of a z-square value of 2. That's where 1 would be on my standard normal curve. To the left, I find my z-square table. I want the positive table, and I want 1.00, which is 0.8413. And then if I wanted to be two standard deviations to the left, so the area of the z-square of 2 to the left would look like that. I look for 2.00, I get 0.9772. So the z-score tables are very useful when we're finding areas to the left of z values that I can't easily determine. Because if I look at my curve, if I calculated something right here, there's no way of me determining what the area of this portion of the curve is. It's not a rectangle, it's not a shape that I can calculate the area of. So that's where the z-score tables are useful. If I look at class example number 3, determine the area under the curve for a standard normal distribution for each of the following z-score intervals and then convert to a percentage to the nearest hundredth. The key to this is being able to read those inequality signs. This says z has to be less than negative 2.15. So negative 2.15 has to be to the left of my mean. This is my mean line. So this could be negative 2.15. And I want to be less than that, so that's this shaded region. So I go to my z-score table, and I look for the negatives, so I need to be on the other sheet. And I'm looking for negative 2.15. And I get 0.0158. So as a percentage, it would be 1.5% of the data would lie to the left of this value. Part B says this is a z-score value greater than negative 2.15. So this is where my negative 2.15 was, but now I'm shading this portion. The z-score tables only give you to the left, not to the right. But I know that this portion here is 0.158 or 1.58%, and everything under the curve adds up to 100% or to 1. So if I went 1 minus this value, that would give me the area to the right, which would equal 0.9842 or 98.42%. So if we look at class example 3B, this says the z value has to be greater than negative 2.15. So it has to be greater, so it's going to go this way, but it has to be less than 2.15. So it's the shaded region in between. Now, if I look up this one, that was my 0.0158. 0.0158. That's going to give me the value from here to the left. If I look up the 2.15, I grab my Z-score chart and I look up 2.15. 2.15, 0.9842. So this is 0.9842, and that's everything from this point to the end. If I subtract these two areas, I will get the part in the middle. So then my area would equal the area of 2.15 minus the area of negative 2.15. So 0.9842 minus 0.0158, which equals 0.9684, or 96.84% of the data lies between these two Z-scores. So what I want you to do is pause and try to do class example number 4A on your own, or all of 4 on your own. And then as you finish each one, you can play and see as the solution is being done. So if I look at 4A, this is a Z-score less than 2.08. 2.08 is positive, it's going to be on this side. My Z-score has to be less than that. So I want the area of 2.08. So I go to my Z-score. I look for 2.08, and I get 0.9812. So this would equal 0.9812. If I look at B asks me for the Z score is greater than 0.92. So 0.92 would be right about here, and I want the stuff that is greater. So remember, when I look up 0.92, what I get, 0.92 is 0.8212. And if I look at this diagram, there's no way that this could be this area, because it's more than half, and this is clearly less than half. This is to the left. So to figure out to the right, I'm going to subtract it from 1. And that will leave me with 0.1788. And then if I look at C, negative 1.75, and negative 1.02 is going to be right here. And I want the area in between. So if I find the area of negative 1.02 and subtract it by the area of negative 1.75, I would get the answer that I'm looking for. So the area of negative 1.02 gives me 0.1539 minus 0.0401 for a total of 0.1138. If we take a look at class example number 5, I'll do the first one, and then I'll give you a chance to do the second one. So the probability, which is the same as area, the probability that the Z-score will lie between these two values. So negative 1.83 and 2.65. So if I look up, this would be my area of 2.65 minus my area of negative 1.83. So my area of 2.65, 0.9960, and negative 1.83 is 0.0336. The difference between those two numbers, 0.9624. So the probability that the z-score value would lie between these two datas is 96%. And then the next one, I have 1.83 and 2.65. So looking at this sketch, I should be able to guess that this is going to be a much smaller number. So the area of 2.65 minus the area of 1.83, I get 0.9960, and 1.83 is 0.9664, which gives me 0.0296. So just about a 3% chance that the data will lie between these 2 points. So what I'd like you to do is take about 15 minutes to work on questions 1 to 3 before you move on to the rest of the lesson. So the next part of the lesson reverses the process. If I gave you the area, could you find the z-score? So the area, if it's written as a percentage, can be changed to a decimal, 0.1762. So what I'm going to do is I'm going to look on my z-score table and find this area. Clues that I can look for: it's less than 0, so I know it has to be in that negative table. So if I go into my negative table, what I'm looking for is 0.1762. If I start looking at the numbers and looking for a pattern, it starts to increase as I go this way. So I look for 0.17. I've got 1, 6, 6s, 7s, right here. If I read that across, that's negative 0.9 and 0.03. So together, that would be negative 0.93. So z-score 1 would be negative 0.93. If I look at B, the area here, 14.92, would be 0.1492. But if I go to look that up on the z-score, it's going to give me something wrong, because remember, I need to look to the left. So the area to the left of the z-score value would actually be 1 minus this amount, which would be 0.8508. That's what I would look up. I know it has to be on the positive side, so I look at the positives. 8508. Take a moment and see if you can find it. Get into the 80s. This is 86, 84, 8508. 1.04. That becomes my z-score value. 1.04. 0.2580. This whole section is here is 0.5. So the whole area that I'm looking up together is 0.7580. And again, I have to be in the positives because my Z sketch shows that it's above the mean. So I look for 7580. Take a moment, see if you can find it. Zero decimal 7 0. So this Z score becomes 0.7 or 7/10. D is probably the trickiest one. What I have to look for in D is I have two Z-score values I have to find. So I have Z-score 1 and Z-score 2. Z-score 2, the one thing that I know is from here to the end is 0.5. So if I take off this amount, 0.5 minus 0.1292, what I get is 0.3708. That's going to be everything to the left of Z2. So I can look that up. I know I need to be on the negative chart, and I'm looking for 0.3707. Right there. Negative 0.33. So the Z-score for 2. So Z2 would equal negative 0.33. I know that from Z2 to the left is 0.3708. So to the left of Z1 would be my 0.3708 minus my 0.2145, which would give me 0.1563. So for Z1, I'm going to look for this number. So go to your Z-score table again and find 0.1563. So when I go to look for this, I have 1539, 1562, 1587. It's closest to this number, so that's the number I will take. Negative 1.0 1. So Z-score 1 would be negative 1.01. So that's reversing the process, using the area to find the Z-score. So now I want you to complete the lesson by doing questions 4 to 7.